Divide and conquer. Divide and conquer is a fundamental algorithmic design technique which is used to solve complex problems by dividing it into smaller subproblems. What will you do with these smaller subproblems? Once you have the smaller subproblem, you will independently solve all these subproblems, and then once the solution is finalized for all of those, you will merge the solutions back to get final solution. This is what you call as divide and conquer technique. So what is the basic idea here? The basic idea is whenever you have the larger problem with you, you have to recursively divide this into smaller and smaller subproblems. What did I mean by recursively divide it? That means you have to keep doing this division process till the point you reach a subproblem which is small enough so that you can directly solve them. Initially, what was the problem? The problem was a complex, large problem which you cannot directly solve. So you decided to divide it into smaller problems. You have to keep dividing till the point you reach a smaller size which you can directly solve. So whenever you can directly solve, you will solve the problem, find the solution for all these smaller subproblems, and then you have to merge these solutions back so as to find the solution for the parent problem. Like this, if you keep merging, finally you will reach this top position where you will have the solution for original problem. This is what is called as divide and conquer algorithm. So why is it called as divide and conquer algorithm? The reason is the two key steps in this algorithm are the divide step and the conquer step. So whatever we learned here, that is dividing the larger problem into smaller subproblems, this step is called as the divide step. So at the end of divide step, you will have subproblems of the original problem. And what is the conquer step? What is conquer here? You're solving a problem. So when you are solving a problem, what is conquer for you? The solution for the problem. That is when you can say you conquered the problem. So whenever you reach a point where you can directly solve the problem, what will you do? You will conquer that subproblem. Similarly, you have to conquer all the subproblems, and this is when your conquer step is done. After the conquer step, you have to merge all the solutions. So once you merge, you will get final solution, which is the solution for your original problem. The next question is, what are some of the divide and conquer algorithms that we have seen in this lecture? In this lecture series, we have already seen some of the algorithms which are solved by divide and conquer technique. For example, merge sort algorithm. We had seen merge sort algorithm. This was a divide and conquer technique. How is it divide and conquer? You wanted to solve a larger array. Let us say you want to solve this array. What did you do? You found the midpoint of this array and you made two smaller arrays. These smaller arrays, they were both half the size of the original array. What did you do then? You again found midpoints of these smaller arrays and you kept dividing it into subproblems till the point you found single element. So whenever you reached a point where your sub array had only one element, what happened? This time the problem is small enough for you to directly solve them. How can you directly solve it? Because you were sorting the array. Whenever you have one element, single element, it is by default sorted, which means at the point when you have only one element, it is by default sorted, and hence you have conquered the problem here. So after conquering, you merged the solution back so as to get the final sorted array. This is merge sort algorithm. Similarly, we had also seen quick sort algorithm. So these all are examples of divide and conquer. In quick sort, what did you do? Every time you had a pivot element which you placed at the right point, and then you divided the larger problem into two smaller problems which were on either side of the pivot. Again, you did the same process. In both those sides, you found the pivot element. Using the pivot element, you will place pivot at the right position and then solve independently for both the other sides of the array. This is also a divide and conquer technique. Then the question is, what advantage are you getting by using a divide and conquer technique? Why can't you solve the same problem by any other technique or even maybe by brute force? So the answer is, there are certain advantages that a divide and conquer algorithm will give you. The first advantage is efficiency. Whenever you apply divide and conquer, it reduces your time complexity. How does it reduce your time complexity? Let us just take the example of merge sort that we had seen. If you want to sort, let us say you would generally take order of n squared time. Instead, when you applied divide and conquer, you brought in merge sort algorithm. What did you do? You reduced this time complexity to order of n log n. So you were able to produce results much faster when you applied divide and conquer than what you were getting without divide and conquer. The second thing, the second advantage that you get is simplicity of the algorithm. So the reason I say simplicity is that whatever problem you initially have, that is a complex problem, a larger problem, a complex problem. This problem is simplified to the simplest possible problem by your divide and conquer technique. If you take the example of merge sort, initially the problem of sorting the array was a complex problem. Let us say it was a larger complex problem. But once you divided it and finally reached a point where there is only one element in the array, you simplified the problem, because when there is only one element, it is by default sorted, which means you simplified the problem and made it a smaller, simpler problem. So what is the next advantage? Next advantage is parallelism. How does it introduce parallelism? Whenever you apply divide and conquer, you generate sub-problems. And what are the advantages of these sub-problems? All these sub-problems are independent of each other, which means you can parallelly solve all these sub-problems and find the solutions. Why can you do it parallelly? Because the solution to any sub-problem will not depend on the solution for other sub-problems. So because of this, if you have the facility to do parallel processing, you can apply it in a divide and conquer algorithm. And the last advantage, fourth advantage, is ease of implementation. How is the ease of implementation applicable here? Generally, whenever you apply a divide and conquer algorithm, you will go for recursive approach. And when you apply a recursive solution, it is generally straightforward to implement. Let us say you want to recursively merge this array. So you are dividing it recursively into smaller and smaller arrays, which is straightforward to implement. So it is intuitive and straightforward. So that is why it is easy to implement. And what are the downsides or the disadvantages? The same recursion produces some disadvantages. For example, you will have overhead. Because of recursion, it will introduce, let us say, some additional overheads to the function calls, and let us say memory usage. If you consider memory usage, each of the recursive call will add an additional entry to the recursive stack, which means your memory is getting used for each of the calls that you're making. So when you're dividing it into smaller and smaller problems, you're making more and more recursive calls, and this will increase your memory usage. And the third disadvantage, this is something you have to think about. This is that your solution is not always optimal. This is the problem you have to look about in divide and conquer. If you apply divide and conquer to an algorithm, to a problem, it may not always give you optimal result, which means you have to be aware of when exactly to apply divide and conquer and get the optimal result. So our next question is, which are the conditions or what properties are to be satisfied by a problem if you have to apply this divide and conquer algorithm. That is, you should know that if you apply divide and conquer algorithm to this problem, you will get the optimal solution. If you want that guarantee, what properties should be there in a problem that you're solving? So this is one important part about divide and conquer. Whenever you are applying an algorithm, you should know exactly when to apply this algorithm. So these points that I'm going to give you, this will tell you exactly when to use a divide and conquer algorithm. So the first thing you have to see is divisibility. What is divisibility? You can call it divisibility, or let us say problem decomposability. So what this means is, your problem, whichever be your problem, this must be divisible into smaller problems. You can't take any random problem, divide it into smaller subproblems and easily solve it. Instead, your problem should have this special characteristic that it should be such that you can divide it into smaller subproblems. So this is what you call as divisibility. It must be divisible into smaller subproblems, and all the subproblems have to be of the same type. And the second thing you have to look for is optimal substructure. So in case of greedy algorithms also, we had seen for optimal substructure. In case of divide and conquer as well, optimal substructure is important. What is optimal substructure? Optimal substructure means the solution for the original problem or the larger problem. This must be constructed from solutions for your smaller problem. Let us say you found all the solution for smaller problem. There should be this guarantee for you that from the solution for your smaller problems, you will be able to find the solution for the larger problem. This is what you call as optimal substructure. And what is the third one? Third property is independent subproblems. We saw that we are forming a lot of subproblems. Let us say you have a complex problem and you formed many subproblems of this complex problem. You should have this characteristic that all these subproblems have to be independent. If it is not independent, the problem is solution for one of the subproblem will be dependent on the solution for other subproblem, which means this whole point of dividing it into smaller problem is no more valid, because now your subproblem is again dependent on the other subproblem. So this property is again one thing which you have to be aware of, that your subproblems should always be independent. They should be such that you can solve all those independently. And what is the fourth property? Fourth property is efficiency of merging. What is efficiency of merging here? Let us say you have a lot of subproblems and you found the solution for these subproblems. Merging all these solutions to get the final solution, that should be efficient. If that is not feasible, then there is no point in dividing it into subproblems and finding solutions for all of those individually. After finding the solution, merging them back and finding the solution for final problem, that is the original problem, that should be feasible. So these are the four properties you have to see if you want to apply divide and conquer. First one is divisibility, that is the larger problem. You should have an option to divide it into smaller problems. Second one is optimal substructure, that is once you divide it into smaller subproblems, if you get the solution, then forming all these solutions and merging them back should give you the solution for the original problem. Third point is about independent subproblems, that is each of the subproblems that you are having, they should be such that you can solve them independently. And the final point is about efficient merging, that is merging all the solutions back to get original solution. That should be efficient and feasible. So this is it about divide and conquer technique. In the coming lectures, we'll see many divide and conquer algorithms so that you get accustomed to this technique and you know how and when to apply divide and conquer. In case of merge sort, quick sort, etc., we already discussed this under sorting algorithms. So whichever are the remaining divide and conquer algorithms, those algorithms we'll be going through in the coming lectures.